All right, the ABCs 1, 2, 3 is a Grasshopper for Rhino. We're going to activate the last set of nodes in the Surface tab, which will be Utilities, and we'll run through and see what we can do with those. So let's zoom back out, keep in perspective, put it so we see what we're doing, and let's start with the first node, which is basically dividing a surface. So all I did was take some lines, I lofted them. I have a surface that's not planar. Basically, I've divided that surface up into its points. That's it. You get your normals. You get some pretty cool parameters of where they are situated in there as a UV point. As points, and then the parameters of where they actually are, which is nice. Have a look through there, and they've been grafted into each row, so you can flip matrix. Say you wanted to interpolate those curves in another direction. You get your normals and you get your points. Surface frames, same thing. You're going to take that surface and you're going to be able to grab those planes off of all those surfaces. And really, you're thinking along the lines of how you thought in curves with horizontal and vertical planes and points along there with a T parameter, and now you have a UV parameter. So that said, let's take a look over here. We've got dimensions, which actually takes the surface and pulls out the dimensions, which is pretty cool. And I use that a couple times. But what I've done here is I've grabbed the loft and I've grabbed a scale. I've rolled it down and I've rotated. So I actually have two surfaces to play with, this one and this one. And what I've done is I've done a copy trim tool on there that when I look at it, it actually gives me the dimensions of the one within that frame, and then also the dimensions of the other one, out the copy trim. And you can see the dimensions change. But we're going to end up using that and do a few things as well. Another thing to try out is to grab a circle surface and pair that with that other loft surface, and you'll see you have the same thing. A copy trim, which basically takes the UV data from one and puts it on another, and you can see how the data changes between that form and that form. So that's the circle versus the original surface, and this is the surface versus the untrimmed surface, and you're getting different U and V dimensions on each one. Interesting to look at. Anyhow, grab it again, loft it together, get yourself a construct 2 domain 2, put it into reparameterized surface, and all of a sudden you have control to grab a section. And think of the point that's within here, this point right here on this corner. That's a very interesting point to deal with to find surface normals, and we'll end up using that several times again in different scripts. I've grabbed a cylinder, which is very, very small for some reason. I'm not sure why I grabbed a tiny one. I put a brep to it, and then I have a cap holes brep, which is going to be basically the same because I've not done anything different. The only difference between here is it caps many holes as possible in the brep, and if I right-click on this one, help, the difference between that one is it's going to give you, just take a look at the data that it gives you. It gives you how many caps you did and is it solid, true, or false. So it's just, I guess, an extension of what you can do with it. I've grabbed myself a nice large ellipse, put a surface on it, and what I've done is I've flipped that, and you're not going to see anything that happens on there per se, but if you actually were to analyze that surface with a MD slider and evaluate surface, you're going to find the vector that's here, and I don't have it amplified. Basically, by flipping it, you've got the vector coming up, and you're flipping it in the other direction. So you've actually flipped the surface of that. So this one's pointing in the down direction, and then this surface, after being flipped, is pointing in the up direction. So that's about it. And you can still have your point on there to where you want to go. And you'll see that there's a difference here because I haven't actually reparametized the surface. So always, when you're using MD sliders, try and get in the habit of reparametizing a surface, and you see you have full access to the whole. Actually, I think I'll choose this one. You'll see you'll have full access to anywhere on that surface as you go. Fun, fun, fun. All right. Lovely. And it actually will go outside the trim surface. Actually, it's not going outside the trim surface, but maybe it is. Hang on a second. Let me check that out. Yeah, it is going to the untrimmed surface. All right. I also have an offset surface, which is very exciting. On this surface, all I'm doing is offsetting that in a direction away from it at a distance, and I'm also offsetting with reference to its control points. And of course, they look the same, but one's moving the control points and one's moving the just the surface. All right, cylinder, again, made. I've capped it, so I have a solid. And this is where it starts to get interesting. Where are the convex edges? Well, looking at this one, what is it? How am I actually, what data is it telling me? Well, it's telling me here as I go into it. Let me go into the help menu. Basically, it's a select concave or convex brep edges. and it's showing you there which ones are concave, which are mixed, and which are convex. And obviously in this one, in a cylinder form, you've only got this true in the convex area. No data coming out of concave or mixed. BREP faces, deconstruct BREP. I think it's the first time we're using it, so I just threw it in there. Maybe not. Maybe I was doing something with it. Let's go back to that surface, the cylinder capped, and we're going to have it move which edges are moving in the z direction. So that's basically choosing a vector and saying, okay, which edges line up to that, and it'll tell you exactly that. And the indice is number 1, and it's mapping 0. All right, take a center box. This is getting a little trickier with edges, but you can figure it out if you play with it a little bit. I've set a center box. I've deconstructed the BREP. I've pulled out a list item that I've actually grabbed edges. I've grabbed the faces. So this face, I've populated that with some geometry. And then I say, okay, edges from face, which edges are close to those points? And that's all it's telling me is these edges are the ones. And then it tells me the indice of 0 through 11 of which edges in that BREP are actually being referred to as the edges with those points. Select the BREP edges to delineate certain faces, and I'm using those points to do that. Same thing, I grab that BREP again, and I'm going to do edges from length, and I'm actually going into here and saying, okay, if my edges are over that length, what do I get? If I go under that length, what do I get? And you're referencing through that list item, the surface, you're getting edges that go over top of that number system and not under that minimum. Edge for linearity, it's still a mystery to me a little bit in the sense of what it means. I pulled it into a maximum parameter and a minimum parameter. Nothing seems to happen so much on this data, but when I start to affect this above 0 as a minimum, all of a sudden I'm getting no reference to anything. So linearity, I've got to look a little farther into. This data coming out of here is pretty intimidating when you look at what's grafted and what you're getting these paths, because you're getting these different parentheses going around it. But basically, I pulled them out 1, 2, 3. What are the edges? What are the indices? What are the maps to populating that geometry, that region? So let's go back up to the region that we're dealing with. This one, I'm populating that with these points and as many points on each one, and I'm ending up with edges from points being referred to, edges, indice, and map. So another one that I've got to kind of wrap my head around why I would actually use that geometry. And the final one is a box, which has an excellent tool here, which it fillets. It chooses those edges and indices of it and chooses which one to edit. So I think that's kind of a cool one. You can take the fillet up real high, and then you can rotate around the edges as to which one you want to have an effect on. That's going to be a very fun one to play with. Anyhow, that's 7 minutes flat.